So I spent some time marking some Year 13 applied papers the other day, and I kind of realised that in terms of maths with applied, the maths you do isn't really that difficult. So let me just fill this in. So when we do Suvat, for example, it's just algebra. It's subbing in numbers, it's rearranging equations. The actual math process is actually quite easy. So where does the difficulty come from? Why is mechanics so poorly answered all the time? Well, it's because when you come to A-level maths and also A-level physics, but that's another story, instead of making the work harder, instead you have to really change your way of thinking. And as soon as you get that way of thinking, it becomes really, really easy. So just so you're aware, when I started kind of tutoring people, which was before I became a teacher, I always found mechanics to be the best thing I could teach, because instead of memorizing a bunch of stuff, instead it was just a way of thinking which I had already had, and therefore I could remember it for a really long time. It wasn't really about my memory, it was more about I just knew how to do it because it's a way of thinking instead. Whereas for something like, tutoring GCSE science, for example, it's a lot more memory and I couldn't really do it until I went over it myself. So the key thing that I want to try and do in this next set of videos is really try and teach you how to think. And whenever I do this as a tutoring practice, or when I teach it, or on the Patreon, I go through this and I really carefully deconstruct why I'm doing what I'm doing. All of the maths you guys can do. You guys can rearrange equations, you guys can sub in numbers. The difficulty comes mainly from actually knowing what to do. So I've gathered a few different styles of questions and from past papers and things like that. So I'm going to teach you how I approach these questions, which again is what I do when I tutor or on the Patreon. So if we read through this, at time t equals 0, a small ball is projected vertically upwards with the speed of u, and from a point A, which is 16.8 meters above the ground. The speed of the ball at the instant immediately before it hits the ground for the first time is 19 meters per second, and it hits the ground that first time at time t equals capital T seconds. The motion of the ball is from the instant it's projected before it hits the ground the first time is modelled as that of a particle moving freely under gravity. The acceleration is modelled as being 10 meters per second squared. So this value, whenever I did those kind of questions from before, people were saying, oh, I use 9.8 instead of 9.81, or I use 10 instead of that. Does it matter? They always tell you in the exam what you should use. I use 9.81 because that's what we use in physics, and that's what we used to use in maths as well, and it is the most common. But again, 9.8, 9.81 or 10, they will tell you. Using the model, show that u equals 5. Okay, so the key thing here is setting up an equation and setting up an idea of what's happening. So I always use diagrams. In A-level maths and A-level physics, if you're doing physics, you have to use diagrams. People that don't use diagrams will make small mistakes and they'll get questions wrong. So if I look at this, we have a ball, starts off here, and is being projected vertically upwards with the speed of u. And this point, in and of itself, is 16.8 meters above. 16.8 meters above the ground. Gravity is 10 meters per second squared, and of course that's going to be going downwards, right? And this is also another thing, is people don't really label their vectors. Remember, everything in Suvat besides time is a vector, which means its direction matters. So far we've got that, and then when it hits the ground, or immediately before it hits the ground, so when it hits the ground again, when it's down here, its speed, so I'm going to call it a final speed, is downwards, and it was 19, was it? 19 meters per second. Okay, now with Suvat, here's the really important thing. If you know 3 things, you can work out all of the other things. So, whenever you're approaching a question, make sure you have 3 different numbers on your diagram. If you have 3 numbers, you can now do the question. In fact, you could do all of these questions. So remember that. You need 3 things. If you have 3 things, it's fine. If you don't have 3 things, sometimes they imply things. So I'll get onto that when we go on to the next questions, but just keep that in mind. So show that u equals 5. Now for part A, B, and C, we're actually going to be using the exact same diagram. Now let's write out our vectors. Now here is where people start to have differing opinions. Now, do you say that what do you say the displacement is? Well, you can change what the displacement is so long as you're consistent. Now, for the purposes of this particular question, I'm going to take downwards as positive. So any vector going downwards is positive, any vector going upwards is negative. And it's really important you do this because it does change what's happening. So if I look, when the ball is down here at its final resting place, its displacement, which is its distance from the starting position, is 16.8 meters, right? Because it started off here, it's gone up, it's gone down, so the distance from its starting position is 16.8 meters. Now, again, it's a vector, which means it's 16.8 meters downwards. So I'm going, since I'm taking downwards as positive, I'll make that 16.8. In fact, I'm going to change it. I'm going to make, and it doesn't matter which way around you do it, but I'm actually going to take upwards as positive. Now, it doesn't actually make a difference. All you have to do is make sure you now put a negative, but I'm changing it so you guys can see why I'm doing what I'm doing. My initial speed is u. I don't know it, it's u. My final speed is 19 meters per second, but it's downwards, so it's negative 19. Okay? And that's actually the reason why I've decided to make upwards positive, is so I can show you all the negatives. If you want to test your understanding, do this question, but take downwards as positive, and you should get the same answer. In fact, you will get the same answer. That would be negative 10, because again, acceleration is downwards. And lastly, but certainly not least, t is equal to capital T, because I don't know what it is. So, what are we trying to work out? We're trying to work out u, and we have v, s, and a. So the equation that comes to my mind is v squared equals u squared plus 2as, which means v squared minus u squared, sorry, not minus u squared, minus 2as equals u squared, which means u is just going to equal square root b squared minus 2as. Okay. So, pull up the calculator and sub in our values. So we have square root, we have b squared, which is going to be negative 19 squared. Of course, we don't technically need to use the negative, but let's leave it as that. Minus 2. A was minus 10, don't forget. So minus 10. And s is negative 16.8. We get 5 exactly as expected. 5 meters per second. There you go. The maths I've done is very simple. I've substituted into an equation. I've rearranged a very basic equation. It's a 2-step rearrange. The only difficult bit is the problem solving. Are these positives or negatives? If I got any of these negatives wrong, my answer is completely incorrect. Okay? What's worse is I could even make this number inside the square root negative, in which case it'll give me a math error, which I've seen many times before. Now for part B, it says find out the value of t. Well, once again, we can use the exact same Suvat. The same Suvat, except now we're working out t. What can we use? We can use any expression we want, any of them that has t in it, because we have every single variable besides t. Probably the easiest one is v equals u plus at. So then if we rearrange that, we have b minus u equals at, and therefore t is equal to v minus u all over a. Subbing in those values, and again we need to make sure we're using the negatives. So we have v is still negative 19, u is 5, so minus 5. If you want, you can use brackets to make it even easier for you to see, so you can put brackets around everything, which I do recommend, like that. So v minus u over a, and a is negative 10. If your signs are consistent, so if you've taken upwards as positive and you make it all consistent, you will always get the right answer. And what I mean by that is, if you get a negative answer, that's fine, it is meant to be negative. This, of course, is time, so it cannot be negative. We get 2.4 seconds. The negatives all cancel out, again, because we are consistent with it. That's 4 marks so far, and again, all we've done is substitute into some fairly easy formulas. In terms of how to memorize these formulas, what I would do is I'd write them all on either a post-it note or a small bit of paper, and I'd keep it in front of me whilst I do Suvat. And that way, over time, you will not need the piece of paper as much. Now here is where things get a bit different. Part C. If you notice, it's 4 marks. So what this implies to me is I'm going to have to set up a new Suvat equation. So the circumstances have changed. And if you look, find the time from the instant the ball is projected to the instant when the ball is 1.2 meters below A. So in other words, instead of 16.8 meters, we're looking at 1.2 meters. That's why the circumstances have changed. That's why it's 4 marks. So let's draw a new diagram. Oops, spoiler warning. Let us go back and get rid of all this. We'll do part C. So what's this new situation I'm talking about? Well, it's still projected upwards at 5 meters per second because that hasn't changed. The acceleration is still going to be 10 meters per second squared downwards. But what has changed is that instead of doing the s as being 16.8, it's now only 1.2. So that's my final spot there. Well, that is 1.2 meters. That's it. Find the time from the instant the ball is projected to the instant when it's below 1.2 meters. Is there any other information we have? No. So now let's write out our solution. Now, if I take downwards as positive or upwards as positive, let's take upwards as positive. Keep it consistent. Again, it doesn't make a difference. Minus 1.2, u is equal to 5. Do I know the final velocity? Nope. Do I know acceleration? Yep. Time is what I'm looking for. So I'm going to write time is time. I normally put question mark as the one that I don't really need, whereas I keep the labeling the same for the value that I want. So, the instant the ball is projected, let's have a look. We have S, U, A, and T. So S equals UT plus half AT squared is the one that comes to my mind. So S equals UT plus half AT squared. Sub in all our values, and that's pretty much it. That's pretty much all we're going to have to do. Then it just becomes a good old-fashioned quadratic. So if I put in half A is minus 10, so I'm just going to make that minus 5t squared. I'm going to move everything over to the left-hand side, so we get 5t squared minus 5t minus 1.2 equals 0. This is just a quadratic, and you know what the best thing about Suvat is, the best thing about mechanics, is they're not testing if you can solve quadratics, which means you can use the calculator nice and easy to work it out. So you don't even need to do the quadratic formula. Although you can if you want to. This is just doing the quadratic formula, but whatever. And we're going to get two values. When x is equal to 1.2. Sorry, t equals 1.2. But remember that whenever we have a quadratic, we have two solutions. They might be the same, but they are two solutions. We get minus 0.2. 0.2 seconds. So, and this is where people get a bit confused. Now, I'm just going to come out and say it. Time can never be negative, which means our time is 1.2 seconds. Now, if you want, you can skip ahead in the video if you're happy with that. Time will never ever be negative in Suvat because it doesn't make any sense, right? But if you are interested in the explanation, let me show you why. Again, you can skip ahead to the next question. I'll leave a timestamp if you wish to skip ahead. If you look at this expression here, it is a quadratic. So in other words, it's modeling the Suvat, the displacement, like this. So we have t along here, we have s along here, and it's going to be some kind of curve, a quadratic curve. Now, if I'm talking about the ball, it's going to go up and it's going to go down, so it's probably going to look something like this. It's been shifted over slightly, like that. Which means, if we're looking for a displacement of 1.2, and yes, I know it's negative, so just bear with me, that's obviously going to have two values of t where it equals 1.2, because a quadratic has two values for every value except its peak. So, but if we look at where we started 1.2 meters above the ground. Actually, no, we didn't. We started, where does it say? 16.8 meters above the ground. So this value up here is 16.8 where we started. So now hopefully it makes sense why this must be a negative time, because it's modeling this as a quadratic, which means if we were to continue back in time, it would be at 1.2 meters. But remember, because we've started at 16.8, we actually disregard everything over here. Because we didn't throw it up and it went through 16.8, it started from 16.8. But that's why we always get two values. It is a quadratic, that's why, but that's why in the model it works. Now I'm going to just jump in right here and say, yes, this is pulleys. We're not going to do the pulley stuff, we're just doing the Suvat stuff. But it's really common for them to stick Suvat in pulleys, and there's really just one trick you need to think of, which in my opinion is actually quite nice. So, we have all this situation, but if you look, it tells me the acceleration is 4.2 meters per second squared. That's actually all I care about, okay? So, fun fact, if you can't do part A of pulleys, you can do part B and C nice and easy, and that's over half the marks done. And I'm going to prove that now because I'm not actually even going to use part A. So, What it's asking us for is, if we read the situation, what's going to happen is Q is going to descend, it's going to drop 0.4 meters, it's going to hit the ground, and it will not bounce. So the idea then is that when it drops, it's going to land here, and then P is going to continue moving. Because if you think about it, these two things are light and extensible. As Q goes down, P is going to go across. It's going to move like that, okay? Now, because the acceleration is only caused by the weight of Q. So when it hits the floor, the weight is no longer pulling particle P. So if you think about it, this acceleration is going downwards at 4.2 meters per second. That is caused because Q has a weight. But the second this hits the floor, P is no longer accelerating. That's the key thing. Which means it's going to continue at whatever speed it managed to accelerate up to. Now, because it's light and inextensible, whatever speed Q gets up to in that 0.4 meters it drops is the speed that P will get up to. Now, here's the next thing. Is P is going to move the exact same distance as Q because, again, the string is light and inextensible. You can think of it almost like a solid rod. So if I push one side of the rod, the other side moves by the exact same amount at the exact same speed. If I move it a few centimeters to the left, the other side will also move a few centimeters to the left. And if I push it at 5 meters per second, the other side will move at 5 meters per second. That's essentially what the model's telling me. So here's the overall goal. Work out the speed which Q gets up to in that small distance, and then work out how long it would take you to travel 1.1 meters, because we've taken off 0.4, at that speed. That will be the time taken for it to hit the pulley. Quite a lot. So I would say for particle Q, let's have a look. S is equal to, and let's take downwards as positive because there's no need to take upwards as positive because there's no upwards vectors. S is going to equal 0.4 meters. U is going to be 0 because it starts at rest. V is what we're looking for. A is equal to 4.2. And we don't know and don't really care about what T is. So I would say V equals, no, I wouldn't say that, sorry. V squared equals U squared plus 2AS is probably our best bet. U squared plus 2AS. U is 0, so we don't even need to worry about that. So V is just equal to the square root of 2AS. Once we work out that, that is the speed at which P is going to be moving. It might also be a good idea to work out the time it takes as well. So go back to our calculator, go back to the normal mode by pressing menu and then 1. So square root 2 times 4.2 times S, which is 0.4. So our particles will be moving at 1.83 meters per second. Now, it might also be, and like I said, it would be a good idea to work out the time, because why? Well, it says, how long will P take to hit the pulley? If I only do this part of the journey, I'm not including this beginning bit. So let's also do T. So what's the best equation? Probably V equals U plus AT. So T is equal to V minus U over A. Sum in our values and we get the T, and we're going to add that on. So V was 1.833, blah, blah, blah. So we do answer minus U, which is 0, over the acceleration, which is 4.2. We get, it takes let's say 44 seconds. Does it give me a nope. So I normally give things to 3SF, so let's just do 44 seconds. I know that's not 3SF, by the way, it's 2 decimal places, but my answer is going to be hopefully bigger than 1 second. So that's the first part of the time. Now for particle P, we don't need to use Suvat, because if you think about it, acceleration is now 0. So we can literally just use the fact that speed equals distance over time. Which means we want to work out time. So time is going to equal distance over speed. The distance we're traveling is 1.1 meters, and we're doing that at 1.83 meters per second. So again, if you want, you can use Suvat, but bear in mind acceleration is 0, so a lot of this stuff is actually going to cancel out, and you're just going to be left with speed equals distance times time anyway. Distance over time even. God, that was embarrassing. 1.1 over 1.83, and we get 0.60 seconds. So the total time is 0.44 plus 0.60. It looks like my guess that it was going to be over 1 was correct. 1.04 seconds. That's 6 marks. Again, the numbers, the maths isn't tricky. It's all problem solving. And unfortunately in GCSE maths, we don't really teach you that much about problem solving. Not that much. So you don't really know how to think like a mathematician, which is the problem. But hopefully this makes a bit more sense in how you approach it. It's all about applying your logic to the situation. I would be curious to see if you could pause the video now and actually attempt this question. Again, remember the first thing is always to draw a diagram. I'm going to assume that you paused it and did it. So if we were to draw this, we have a ball, right? That's all I've read so far. It's a ball thrown into the air. It is 2 meters above the ground, so let's do that. The reason why I draw it like this with the 2 meters is because A, it's like a length, but B, I don't actually know which way they're going to ask me to do displacement yet, because I haven't read the rest of the question. So vertically upwards with a speed of 9 meters per second. Meters per second. And gravity is 10 meters per second squared. And that's it. And it says it hits the ground t seconds after leaving. Find the value of t. Well, if it's hitting the ground, then that means my displacement is going to be downwards. Now, I'm going to take upwards as positive. That's just the way I do it normally. That would be -2. U would be 9. I don't know what the speed will be when it hits the ground, but I also don't really care. A is -10, and therefore t is just equal to t, right? In fact, if you want to be really precise, we can even call it capital T, just to make it super clear what we're working out. So we have S, U, A, and T. So that is going to be S equals UT plus half AT squared, and once again we're going to be using the good old-fashioned quadratic formula. Half AT squared. Yeah, that's unfortunate. Okay, -2. We get 9t minus 5t squared. Move everything over to the left-hand side. We get 5t squared minus 9t minus 2 equals 0. Once again, quadratic formula done. 4 marks. Again, without a diagram, I personally wouldn't even attempt a question, especially with some of the harder ones you get in the exam, like we had before with the Pulley. You need a diagram. Sometimes they give you one, but with Suvat questions, they never give you one. So bear that in mind. And when I say this, I mean it for pure, I mean it for stats, I mean it for mechanics. Stats, diagrams, okay, that might be a bit tricky, but I'm thinking more for stuff like probability, you'll need a diagram. But, you know, I get that you can't always use a diagram with all the topics. But again, pure and mechanics, 100%. And if you do physics, definitely. We get t equals 2. In fact, let's do capital T equals 2. And capital T could be, I'm guessing it's going to be negative 0.2. So which one do we take? Well, remember, we always take the positive value. 4 marks. It's not that bad. Again, they give you extra marks because if I'm being perfectly honest with you, questions are really poorly worded. Really poorly answered as well. You get marks for choosing the right equation, for an attempt to do an equation. So if you just write out the variables, they can give you a mark for that too. All sorts of stuff. So just keep that in mind. Draw diagram. Here we have the last kind of question that we're going to go through, and it's a pretty good one because it comes up with 3 different kind of scenarios and things you need to calculate. So again, what is the first step? Draw a diagram. So let's do it. Now here you notice they didn't tell me what acceleration is. Let's just take it as 10 because in the rest of the questions they took it as 10. If they don't tell you, you can just use 9.8, 9.81 or 10. You get it fine, but again in the exam they will always tell you. This is a question that's kind of old, where they used to just say take 9.81, but let's just take 10 because it's funny. So, projected vertically upwards with a speed of 18 from 0.2 meters above the ground. See what I'm doing? And again, let's just take acceleration to be 10 even, see? Freudian slip. And upwards would be positive. And it says the greatest height achieved by the stone. Now, S is what we're working out. U is 18. B is what? Well, actually, no, let's fill in the rest. I know it's a bit of a spoiler, but we don't know the rest, right? So we have U and A, and I want to work out S. I told you before you need to have 3 things to work out Suvat. We only have 2. Well, think about it. Greatest height reached by the stone. Well, if I throw something up into the air, it will go up, it will go up, it will go up. It will stop and then it will come down, right? Everything that goes up will come down eventually, unless you throw it really hard. Okay, but assuming you're not like the Incredible Hulk, throw it up and it'll come down. If you notice what happens when it goes up and comes down, what happens in between that? Well, the velocity goes from positive to negative, right? In my diagram, it goes upwards, positive, negative, which means at the instant it hits its peak, it is stopped. The velocity is 0. Because again, to go from positive to negative, you must go through 0. There is no exception to that. So, the peak height reached by anything, when you throw it in the air, shoot it in the air, whatever, is when the velocity hits 0 meters per second. I mean, think about it. If it was still positive, then it would still be going up, which means it can go slightly higher. So, now what do we do? The equation that comes to mind is v squared equals u squared plus 2as. V is 0. So if we're looking for s, then s would be negative u squared over 2a. Just trust me on that one. Sub in our values. So we have, go back to menu, there we go. We have negative, and then in brackets u squared. I would always do that just to be super, super, super careful. Minus 10. And again, don't worry about the negatives now. A lot of people look at the negatives and they panic and they panic and they panic. Don't panic. Just put them in and they will cancel out. 16.2 meters. So job done, right? Nope. This is where they really screw people over. They kick you in the nuts. Because look, the greatest height reached by the stone. That's how high it goes from this point. The greatest height would add on 2 meters. So then I would then write just a little thing here. Height will equal, and I'd make it explicit what I'm doing. I'm adding 2. Okay? Just so your examiner can see that you know what you're doing. So that first part is only worth 2 marks, which makes sense. If you remember our previous questions, it was 2 marks for quite a basic thing like this. Now, part B, we're probably going to have to use the new Suvat because it says the speed with which it hits the ground. Well, what's S now? S is not 18.2. It hits the ground, so it's gone down by 2 meters overall. So it's negative 2 meters. U is still equal to 18. B is what we want to work out, so I'm going to put that as a big fat V. A is minus 10. And time, I don't know, but if you look, that's actually the answer to part C, so of course we don't know it. Well, again, do we have 3 things? We have S, U, and A, which means we can work out V and T. That's what that means. If you have 3, you can work out all of the other variables guaranteed, because there's an equation for all of them. So, V squared equals U squared plus 2AS. And then all you need to do is square root it afterwards. See? Nice and easy. Once you've laid it out, once you have a diagram, once you are confident. Now, of course, the biggest problem with mechanics as well, other than the fact that it's very hard to remember what you're doing, is the unfortunate truth that you never know if you're right. And that kind of sucks. Whoa, 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 whoa. Something bad is about to happen there. Square root answers what I meant to wrote, right? 19.1 meters per second. And then the next part is just, hey, how long does it take? Well, we can use any equation we want. V equals U plus AT is my favourite because it's very short and easy, but you can use S is UT plus half AT squared. You can use whatever you want. Let's just use V equals U plus AT because it's on my mind. Now, keep in mind, this velocity is actually a negative velocity because it's going to be heading downwards, okay? So, when I sub it into here, it's minus 19.1. Just remember that. So T is equal to V minus U over A. B is minus 19.1. U is 18. All over minus 10. So let's sub it in. Minus 19.1 minus 18 all over minus 10. Gives me 3.71 seconds. The time is positive because time has to be positive. And that's it. So this was requested, just so you're aware. So if you do want me to go through some other parts of mechanics as well, I don't mind doing that. But again, think more about my process. So why am I doing this? Not what I've done, but why have I done it?